In this video, I'm going to show you how to create a Labview program to power your voltage divider from the analog discovery, and also to measure the voltage at the output between the resistor and the thermistor through the oscilloscope functionality of the analog discovery. So you can see here we have our Labview screen. We have a block diagram where we write the program, and we have the front panel, which is like our variables and constants, and also the output. So those are the two windows that always open and that you'll be using. You can see over here we also have like a tools menu, and so we can switch between the pointer, the other pointer, the text, and then the wiring. So just so you can see it, the wiring feature, we'll use that a lot. The other thing I wanted to show you is context help. So what context help does is it shows you how each of the VIs, or the little functions, need to be wired. And then the other one thing I wanted to show you is the functions palette. So it must be open already. Let's see. See here, there we go. There's the functions palette. And we'll be using some of the functions in here, but we'll a lot of times be using the Digilent waveforms software, which comes automatically with the analog discovery, but they've created VIs to use in Labview, and so we're going to use two of the functionalities, right? So we're going to use the waveforms power supply functions, or VIs, and we're also going to be using the waveforms oscilloscope functions. So those are the two places we'll be looking for VI blocks. So let's get started. The first thing we want to do is, we know that we're going to be measuring temperature over time, so we need something like a loop so that we continually are able to measure the temperature. So we're going to look for a while loop. So I'm going to pick a while loop, and I'm going to draw that in here. Okay, and in a while loop, I want to be able to like stop it from the control panel, like over here. So what I can do is on this little stop sign down here, if I go to the wiring feature, you can see there's I can wire it to something. A little like dot comes up with like a wire, and so if I two-finger click it, I can create a control. So the control means it's something that's going to be on the front panel. So I'm going to create the control, and it picked a boolean, and that's because that's the wire. So if I look at it with the context help, let's see here, that doesn't really show it, but the wire, like when I hovered over it with the tool, I could tell it was a green, and so that helps me to know like that's a boolean. And so you can see over here, this is the stop. So what if I push this button when it's running, it's going to stop the loop. I could also push the stop sign, or just the stop sign here. Either one will stop it, but that's just good programming, is to have a stop that is available to you on the front panel of something. The next thing I want to do is, this is kind of weird, but you'll get it as we go. I want to add in a structure, and I want to do a flat sequence, and you'll see what it does in just a minute. So I'm just going to go here to and put it in here, and kind of move this out of the way a little bit. And now, so the reason I want this is because I want to be able to like do things in steps. So the first thing we're going to do is we're going to turn on the power supply for the analog discovery. That's the first step. And then the next step is going to be to measure the voltage. So let's just have like our two steps. So I'm going to say first, I want to replace this with a stacked sequence. So what that means is, that you'll see in just a second, when I add frame after, I have the 0th frame, so that's going to be turn on my power supply, and then the first frame is going to be measure the voltage, and then I'm going to have two more frames also. So I'm going to do add a frame after and add a frame after. And so the reason why is because the very first one, the 0th frame, is turn on the power supply. The first frame is measure the voltage. The second frame is calculate the resistance. And then the third frame is calculate the temperature. So we're just using this sequence to do it in steps. So it kind of like cleans it up a little bit and makes a little more sense. So the first thing for the power supply we want to initialize. So there's a couple of VIs that I need to use to initialize the hardware. So I'm going to go to power supply, and I first want to click on initialize, and I want this outside the loop. Like I only want to do this once. And there's another function I need. So I can, like I said, I can go to view and find the functions palette, or I can two-finger click inside my block diagram and it'll bring me here too. So I've been doing a lot of two-finger to access it. So I go here, I'm going to power supply, and this one I want, let's see, I want enable. So I'm going to enable the power supply. And what's nice, do you see that it connected it automatically, which is really nice. And then when I use my context help, so it just feels like everything's kind of in the way, but it is helpful. So if I go over here and I bring up my context help, let's see if I close the functions for a minute. This is the initialize, and so it needs a device name. And if I switch to my wiring tool, it shows me device name. And so I'm going to two-finger click. See if it'll do it for me. And it doesn't give me what I want. So if you notice, it's pink and it's a name. So that means I need a string. So I'm going to go over here to string. Oh, did you see that? String here. And I'm going to get a string constant. And I'm going to type that here. And this is we're going to type in here analog discovery 2. Just make sure you spell it right, because it's looking for the correct name, and it'll give you an error if it's not correct. The other thing I can do is, let's see if it'll let me do this. Maybe not. It usually lets me tab through the tools, but it's not letting me do that. So I don't know if that functionality is going away or not. Got that. Okay, and the other thing I need to do right here, you see there's an enable output. So I'm going to do the Boolean palette and grab a true or false, put that here, and then wire that over there. And it's true. That's great. Oh, actually, I think this isn't what I want. I'm going to undo that, or yeah, I'm going to do Control-Z just to undo it. I really want this to be a control. So I'm going to do create control. And so this is enable outputs. What this really is it's saying turn the power on. So power on. So if true is selected, so meaning like over here on my panel, now the power is on, right? If I click it again, it's off. But you can turn the power on, so that means, hey, turn the power on to my analog discovery, so it'll power my voltage divider. Okay, so I think I've got everything there. And then the other thing I need to do, anytime I have something like initialized or turned on, I need to turn it off or close it over here. So I'm going to go to Functions Palette again and grab close. So I just want to, let's see, put it here. And then the other thing I want to do is I want to have an error signal. Let's see if I can find. I'm just looking for dialog and interface. That's what I want. And I want just the simple error handler VI. There we go. It's going to connect it for us. Great. Okay. That's great. So we need to actually do things here now, right? So here inside my 0th frame, I'm going to add in turning on my power supply. So I need to choose configure the voltage output. So that's going to go here. I'm just going to put it here. And then I need another function. And, oops, here. I need to enable it. Or no, I need to read the output. So I need to read the output. Okay, so wire these up. I'm going to drag these up so they're like more in line here. And I'm going to wire this through. I needed to wait till now to wire it through because it won't connect otherwise. So like it won't make these connections on the for loop and the sequence unless something's over here to connect to. So just that's why I didn't try to connect them through before I had them here. Get that through, and then see if I can get rid of the context help for a minute. And I'll bring these VIs up and wire that through. There we go. Okay, and now, so I just want to make sure I have 5 volts on here. So I need to, I need the voltage level. So I'm not going to wire up the current, but I am going to wire up the voltage. So I'm going to create a constant. And I'm just going to type in 5. So I want it to be 5 volts. Then I'm going to move it out of the way. There we go. And I don't want it there, so there we go. And then the other thing I need to do is it needs to have the channel information here. So I'm going to go to string palette. I'm going to type PS for power supply / +5 capital V for volts. So it has to be exactly like that because it's referencing one of the lines coming out of the analog discovery. So it needs to be, if you look at the documentation, it'll tell you that you need to wire it that. And make sure you have that just so. Okay, and then the last thing I want is the output. So the actual voltage level is right here. And I'm going to have an output, or an indicator, right? An indicator right here. So this is going to be my actual voltage. And if you see over here, we can see it, actual voltage. So if this is running correctly, when I press, turn the power on, I should see 5 volts here. And that's just a check to make sure, hey, I have voltage going to my voltage divider. Okay, great. So, the next thing we have to do is we need to measure the voltage. So the way we're going to do that is we need to use the oscilloscope. So again, we need to initialize things about the oscilloscope. So I'm going to go to the function palette, and now instead of the power supply, I'm going to do the oscilloscope. So I need to initialize. So that's going to be here. And then I need another one. Let's see here. And this one is configure the analog channel. Great. And I'm using the analog discovery, so I can plug that right in here. I need to have the right channel here. So see if it'll get me the string palette. Yep. String constant. So here I need to, again, write it exactly right, lowercase MSO 1. That means the first wire in the top row of the analog discovery. There we go. And then I need enable channel here. And this is a constant, and I want it to be true, so that works. Get that out of here. Okay, there we go. And I need a few more things. So here, I think this is a constant. So this is the kind of signal, so it's a DC signal, right? It's not it's measuring a DC signal once in a while. Now the probe attenuation, we just want to be 1. So I don't think I got it there. There we go. So that just automatically fills in. Those are the defaults, and we'll take them. And they're wired in to different places. You can see, there we go. Okay, so inside here, we need a run function. Okay, and then we need, I think, a read function. Yep. All right. Again, we're connecting across. And we also need a close over on this side, just like we did for the power supply. And then I'm going to just copy and paste the error. So I just used Control V, or Control C and Control V to copy it and then paste it. This one through the handler. I just want to go back because I think I didn't get the handler across on this one, which I needed to. Oh, that's not what I want. I want the handler, so the blue. There we go. That would have given me an error for sure. Okay, next I need a, I think a waveform. Let's see if I find this right. It's this one, indexed waveform array. I'm pretty sure that's right. Okay, and I'm going to take my analog waveform and bring it up into here. So this is because sometimes I can have multiple waveforms that I'm reading all at the same time. I don't in this case, so my index is just going to be 1. Right? I could be reading like 5 different signals all at one time, but I'm not. I'm just reading 1. But that's what it requires you to do, to pull out the reading from one channel. And now I want to do, I think this is under signal processing, and then I just want RMS. There we go, basic DC RMS. Nice, it hooked it up for me. And now I can have the RMS value. I'm going to have an indicator. And so you can see the value, the RMS value, is right there. And so this is actually going to be voltage. So this is our, we'll say V out. This is the output between the thermistor and the resistor. This is our voltage in between those two resistive components. And I want to see the time varying signal for that. So I'm going to go over here and I'm going to 2-finger click to get controls, and I'm going to add a graph. So this is the output that I want to see, and I'm going to choose waveform chart. Let's see here, and this is going to be V out. So the voltage in between those two resistors. And I go back over here, and I'm going to connect it. So they both are going to, one's the output, so we'll just be able to see the value here, V out. And then this is our chart, so we'll be able to see it changing in time. That's great. So now we're done with this part. We've got our voltage. And we'd want to run it now. I'm not going to run it because I don't have analog discovery at home with me, but you would run it now and you want to see, hey, does it make sense? Like, what am I expecting to see? Something between 0 and 5 volts, right? If I have 0, that means I don't have power maybe. If I have 5 volts, that means maybe there's something wrong with my circuit. It's not hooked up. I should have something kind of in between 0 and 5. Okay, so next we're going to, we need to convert our voltage to a resistance of the thermistor. So we're going to use an equation. And the way I do an equation is I'm going to go to mathematics, and then scripts and formulas, and go to the formula block, and put the formula block in. Okay, so the way this works is you write a formula here. So in the slides that we have for this lab, you have to convert your output voltage, the equation for the output voltage of a voltage divider. is equal to, so V out is equal to the supply voltage, Vs, times R2, which is the thermistor resistance, divided by R1 plus R2. And then what you need to do is do some algebra to get RT on the left and all the other variables on the right. So, so the other variables we know are going to be the supply voltage, we'll say Vs. The output voltage, we'll say V0. Oops, 0. And we need R1, right? That's the resistor that we pick to go with our thermistor. And so those are the three variables. And then where I don't have R2 here because that's going to be the output from here. So when you have an equation, usually you have, like, say, we would have RT is equal to something. And I'm not going to say what the equation is because that's yours to figure out. But let's just make something up, like Vs times R1, and this was wrong, right? Say divided by V out. Completely wrong. So make sure you change it. But that's how we might write an equation for if we were solving for RT. But the way this works is we delete everything before the equals. So we just leave the equals and RT equals. We take that out, and this is the result. So remember, that equation is wrong. You need to solve it for yourself. But you can see what's cool is I have all of my inputs and I have my result. So how do we get these inputs? Well, let's just talk about R1 is something that we pick. So we're going to make this a control. Two-finger click, create control. And so you can see R1 just showed up over here. Great. Our Vs is our V supply voltage. So what we can do is grab that from this actual voltage value. So the way I can pass that through is I can, it's called add sequence local, right? So it allows me to pass this actual voltage through to a different frame. Okay, so that means I can wire that. This is Vs. I can wire this to Vs. And let's just so we remember, let's like put let's put a little label here. So I'm just going to add a string constant to help me remember. This one's Vs. Okay, and now I'm going to go to back here, and I need V0. Like, that's the output voltage. That's this value. So I'm going to add another add sequence local and connect to here. Just don't know if I got it. There we go. Okay, and I'm going to add another string just to remind me. So this is going to be V. Oh, or V out. Let's do V out so we know that's what it is. Notice too, like Vs is coming out of here, but notice I can't have V out come into here because it's only passes things to the next scene. So okay, so now we've got, let's do another just string so we know what we have here. This is Vs. String. This is V out. Right, and so I'm going to wire this V out here. And now I just have my result. So again, I want to do an indicator. So that's going to show up over here. It did the result, and we're going to call this V out. And you'll see it'll change over here, V out. And I also want a graph. Wait a minute, that's not V out, sorry. This is the R sub T, right? RT for the thermistor resistance. That's what it is. So that shows up over here, and I want a graph of RT, so I'm going to go over here and do graph. Put that right there, and we're going to call this resistance of thermistor. And so both of these are going to be changing, right, over time. If it heats up, if the thermistor heats up, we'll have a different R value than if it doesn't heat up, right? So, all right. So this is, I think we have everything done here, and the last thing we want to do is calculate the temperature. Oh, I forgot one thing is to hook this up. But in order to determine the temperature, we need RT. So we're going to do one more of these add sequence local, and wire this up. Okay, now I'm going to add another string. This is RT. Right, so now if I go to the third, this is our temperature. This is finally where we'll figure that out. And we know that this is, just to help ourselves to remember, this is Vs. This is V0 or V out. And this is RT. And I put them in that order, like from left to right, so it'd help me to remember. Otherwise I have to keep checking back, which is kind of annoying. Okay, so to calculate the temperature, you're given in the slides a table of values for different kinds of thermistors. And the thermistor we're using is a 10K thermistor. So if you go to the column that says 10K, you'll see a whole bunch of resistance values. But on the left-hand side, there's a whole bunch of temperatures. So what you want to do is in Excel or MATLAB or Python, you want to create a column of X's, which would be your resistance values, and a column of Y's, which would be your temperatures, right? And then what you want to do is a fit, so a linear fit. So you want to come up with an equation, remember y equals mx plus b, for that data. And in that case, your y is going to be temperature, and your x is going to be the resistance of the thermistor. So we need another formula. So we're going to go to mathematics, scripts, and formula. Here we go. All right, and so we are going to need m, and we're going to need b. So that's the slope. Well, y equals mx plus b, and then we're going to need RT, right? So what we want is y equals mx plus b, and our y in this case is temperature. So like if I just write this up here, just to show you what I'm talking about, m times x plus b. The other thing is there's no spaces in these formulas, so you got to make sure there's no spaces. Our y now is temperature. We're solving for temperature. And our x is RT. Right, so that's really the equation we're solving for. And remember, for this formula, I get rid of the t. So it's going to output the t, but I don't need to include it right here. Green means I'm good to go for my formula. And now I have the values here. Now you're solving for m and b, so you're doing that separately from here. So that means I'm going to make it a control where you're going to enter it. So this is m, and you can see it right over here, m. And then b, we're going to create another control. Right, so you're going to enter the m and the b right here, m and b, and then the result, well, we have to put in r, right? So we need to come down over here and wire that in. Right, so that's wired into r. So for any r, it's going to use the formula to calculate our temperature. So again, we're going to create an indicator. So it shows our value for temperature. Say temperature. We need a graph. So we're going to put another graph in here. And I'm going to put it down here. You might want to reorganize this so that your temperature is on top and these other graphs are on the bottom. But this is just the way I was thinking about how to go about doing this. Temperature. But if you wanted it to like be able to see it, the temperature well, which is really what you want to see here, you probably want to rearrange these graphs. Just drag them around on the screen. And call this temperature. Here. Wire it up. And I think we're done. And it's amazing. We have our arrow is a solid white arrow. If there are errors. Usually the things that are errors are you haven't hooked up this wire, something like that. Usually it's you haven't hooked something up. But you can always ask or ask somebody else or just go back and watch the video again. I'm going to save this. You probably want to save sooner than right now in case you do something or the computer crashes or something, because it takes a little while, as you could see. I like to save my programs under Documents. Labview, when it installs, creates this Labview data folder, so I'm going to call this Thermistor Labview graph. And I might do analog. I think that's good enough. I think we're good. Just so you know, if you're trying to find it again, because a lot of times you might want to use this again. You remember it's a thermistor. You'll remember it's Labview, so that way it might be easier to find. So name it something so that it's easy for you to find, and that's great. And so that's it. Good luck.